Who of you is using observability in production, whatever that means to you? Okay, quite a few people. Who is using Spring Boot free in production? Oh, yay. Who is using deliberately Micrometer? Yay. Prometheus? Fine. OpenTelemetry? Okay, fewer people. Who doesn't care at all? Okay, nobody. Everybody cares. That's great. So, what is observability? That's an important quote. So, how well we can understand the internals of a system based on its outputs or signals or whatever you call. Because at the end of part number 1, there will be a surprise, like an unexpected output, but still it can tell us something about the system. So now I've been working on open source tooling or tooling as such for a decade, so I have absolutely almost no, let's say, access to production whatsoever, because my production is the tooling and your feedback as users. So today I've decided that I will become a business value giving developer. I will be delivering business value. Finally, after a decade of playing around, I will deliver money. So what we will be doing is we're going to be steeping tea, or brewing tea. So this is our system architecture. I mean, it's not as beautiful as in your enterprise architecture, our enterprise architect software. So in essence, there is an edge service called T-service. When a request comes in, we will be using RabbitMQ to send messages over RabbitMQ to a reporting service that will store the data in MongoDB. Now, T-service will call over HTTP proxy service, which is a gateway. And the gateway will call T-leaf service, and that's going to call a database, so store data in Postgres. And T-service will also talk to water service that will talk to Postgres. So we have apps that are basing on HTTP-based communication, messaging, we have a relational database, we have MongoDB, and we have also reactive and non-reactive apps. Okay, so if you want to sell a product, the most important thing is the UI, right? Because the users are going to the UI. So if the UI is bad, your product will not be great. So I spent a lot of time with my colleagues from the team to create the best UI using the latest and greatest tech out there. So I mean, beyond any, let's just see it. So this is it. That's the. Why are you laughing? This is not funny. It's like 21st century grade UI. I mean, it's reactive because it reacts to my clicks, right? So it's reactive. It's responsive because when I click, look at this, it's responding, right? Or should be. Oh, it's not. Oh, great. Oh, that wasn't me. That wasn't me. I mean, this is unexpected. Of course, like the second before I started this presentation, I had all sorts of problems. So apparently, I have one more. Jesus, what the hell? No route to host exception. Okay, let us retry this. What if only we had observability to debug this? So yeah, I mean, yeah, of course, the demo gods are not with me today. Okay, let's wait for that to ever work. If not, then we'll figure this out somehow, as usual. Okay. No route to host. Like, what the hell is going on? Okay, let's stop this one. Okay. Stop. Any questions so far, right? The presentation is going fantastic. Of course, most likely it's due to Gradle. Who loves Gradle? Okay, 3-4 people. That's a lot. I would assume fewer. Okay, let's wait for the apps to restart. So I'm going to talk maybe a little bit about the architecture of the solution. So we have the apps. They are registering themselves. These are Spring Boot apps using Spring Boot free. They are registering themselves in Eureka. This is why we saw that there is a problem with some gateway or something like this, because most likely there was an issue with Eureka. Let's see now if the apps are there. Okay, the apps are there, so theoretically that should work. Let's now check if the steep part is going to work. Apparently not. Service unavailable. Why is that? I have literally rehearsed this just before, like, the presentation. Oh my God. Okay, but the water service is there, so why is it not working? Oh, hallelujah. Okay, and it's even calculating some stuff. So most likely one of the apps, because I'm running all the apps locally, it took some time to start, to process the request, and to register in Eureka, and it needs 30 seconds to confirm it's being there in Eureka. Eureka is a service discovery tool. Okay, so the worst part is like behind us, hopefully. So, I mean, let me click around to prove that everything looks fine. You see, I can pick different types of tea, and okay, that's an internal server error. Okay, let me refresh the browser. Okay. So apparently, that means that there is a server, and internally, there was an error. But that doesn't help us a lot, I think. So let's try to use the observability solutions. By the way, you're not going to see a full stack observability solution, like I heard like in one of the sessions, because what we're going to be using here is native observability solution that comes with Spring Boot. And the recommended way of doing observability with Spring Boot is not running an agent, is running an inbuilt observability support that comes with Spring Boot. Just FYI, because with an agent, it can turn out that, by the way, one of the most recommended or talked about solutions that is using an agent is scanning private methods of different, for example, Spring filters. And once there was an issue because the order in the private method was reversed, because it's a private method, so the developers can do whatever they want. And suddenly one of the tags was a password that started leaking because the order changed. So bear in mind that agent-based solutions often work on internals that can change. That's number one. And number two, do check if they're production ready, because some of them claim that they are, and they are in alpha mode. So bear in mind those things. Okay, no data. I'm going to go nuts. So this is our observability solution that, believe me, worked an hour ago. Now it does not. And this is a very good question why, but we will debug this. Okay, what is wrong now? So Prometheus should be up. Let's check this out, server. Okay, that should be working. So we have some stuff over here, and it should be there right now. Okay, so why is it not over here? Okay, let's talk about theory then, because I don't know what's going on really. So what we have here, and maybe in the meantime that's going to work somehow, is that our apps are being instrumented using micrometer observation. Micrometer is a project that I work on, and what it gives us is the ability to instrument once and have multiple benefits out of it, which means that the fact whether you have metrics or tracing is a configuration detail. If you're looking at Spring Boot, that means that depending on what you have in a class path, different features will be plugged in. So if you have micrometer core on the class path, automatically you will get metrics. If you have micrometer tracing, automatically you're going to have tracing features plugged in. Let me try to pray here. So what I will do, because apparently this kind of works, but something broke with Prometheus, with Grafana here. I got. Let me refresh this. Let me try to do it manually here then. T-service throughput, because we should have a problem with throughput. We'll see if it works with Prometheus here. Rate interval, let's do it 5 minutes. I think it's like that. Application, T-service, URL. That was T name, I think. Empty query zones. That's very unfortunate. Okay, 15 minutes. Oh my God. Okay. Oh, this is nice. Flux. Nil. Oh, this is a great, helpful information. Okay, what we're going to do is we will restart everything, because nothing else comes to my mind. Okay, let's stop this. Okay, Docker compose up. You know what? I will do one more thing. Maybe it's the VPN. Okay, Docker compose up, a lot of logs, good. Now let's run the apps. Sorry for that, but like it never happened to me before. Of course it had to happen today. Okay. Now, let's see, again, Eureka, are we up? Things are popping up slowly. In the meantime, we'll be looking at, it's going to fetch stuff from Eureka. This is interesting. So we have for metric scraping, what we have is Prometheus. And Prometheus is configured in such a way that it goes to Eureka in order to find all the apps and all the instances, and then it queries those instances. So we don't have to provide static IPs and ports of our apps, but it's going to go to Eureka and automatically fetch the state. So 5 out of 7 are up. That's better. Okay, now one more time. Maybe anything. Okay, no data. Oh, maybe because I didn't click anything. Okay, this is internal server error. That should work. And now, anything? Maybe if I click 20 times, it's going to work. Okay, 7 out of 7. Maybe you have to wait a second. Yay, okay. Whew. Okay, so now I have to speed up. Sorry about that. Most likely that was my VPN. For some reason, it didn't help me out. Okay, so let's run the load test again. It seems that we have people clicking. So we have around 5 requests per second. And the problem is that for the English breakfast type of tea, we do not have proper results. We have an exception. So one way of fixing this would be for you to go to every single server, SSH to that box, in production, of course, find the logs, do a grep for error. Who's using that? Who's doing this like that? Don't be shy. Like, we're friends here. We're not going to tell anybody. Nobody? Okay, very good. Who is actively compiling classes locally and shipping them to a jar that is running in production? Nobody. We can talk later. Of course, I don't do that either. Okay, so yeah, we have a problem with that. So what we can do, by the way, I'm showing you Grafana today and the Grafana stack, but it doesn't matter what you have. Preferably, you should have a solution that allows you to jump between the types of signals in such a way that it's natural, right? So one thing comes from another. So you can jump between metrics and traces and metrics and logs, etc., etc. So what we will do is we will go over here to Explore and search for, go to Loki, which is a solution, and an error occurred with the plugin, of course. this solution takes so the apps are pushing the logs to low-key. Those are cut into pieces, and we can search over those apps. Come on, no logs. An error. Okay, I will manage. We'll manage in a different way. So what we will do is we will go from the tracing side of things. So we will search, oh, there you go. So what I did is I found one of the traces. So for those who don't know, who knows what distributed tracing is? Okay, most people. So for those who don't know, very quick summary. Imagine that when a request comes into our app, it has to go to those other 4 apps to do the processing and return the information about the steep T. So imagine that we correlate all those requests together, so they share one identifier called trace identifier. That means that if I want to have all the logs or all the information about all the processes for that particular business operation, what they share is the trace identifier. And here, I've managed to click one, and I already see that there is a problem because I have the exclamation mark. So we can clearly see here that the operation took 32 milliseconds. It's related to English breakfast. I was lucky to click that one. Now, the T service gets the request, then over messaging goes to reporting service and stores the message in Mongo. In the meantime, T service uses an HTTP call to call the proxy service that calls the water service, and the water service goes to the database. And another request from the T service is to the tleaf service, and here we have an exclamation mark. So if we click it and go here, we can see that resource not found tleaf with name English breakfast. Okay, so we've managed to come to the conclusion that the English breakfast tleaf is missing. Is it true? I mean, let's check it out. So what happens is, if we check the query to the database, we have some sort of a select, fair enough. And the result set contains no entry, so JDBC row count isn't 0. So apparently, it happened for the first time ever. On the UI, we have not synced with what we have on the back end. So we are giving the user an option to query for something which is not in the database. And we're lucky. I don't know how it happened, but I have an endpoint here, like an request ready, that allows us to add the missing thing to the database. So let me run this. The response is saved, so apparently I did manage to store that thing in the database. And if we go over here, we should start seeing that the throughput changes, that the server error rate goes to 0, and the successes go to 5, because we have 5 requests per second. Which would mean that my emails over here, I have like high latency T-house, let's ignore that, nobody cares about that, it got resolved. I mean, you don't do it like this with your errors, right? Alerts like, it doesn't matter, oh, it's a known issue, right, who cares? Okay, so high error rate. Let's wait for that to pop up to 5, and then I should get an email, and we should be ready to go. I mean, I can conclude the presentation just because I have this special request over here that has added the English breakfast. Okay, oh, fantastic. At least something managed to work. So theoretically, I can go and summarize this part because we've managed to fix all the problems that currently our application has. What is this? It's dropping again. Okay, so high error rate, again, something's wrong. Okay, so as usual, we fix one thing and another pops up. Okay, and yeah, maybe if I refresh, maybe it's a problem with Grafana. No, it's not. Apparently, after refreshing, it's the same thing. So, oh, this looks terrible. So we are dropping from around 5 to around 2, from what I see, and it stops. But why is it so? So by the way, those little dots you can see here are called exemplars. So when you have a metric, there is an algorithm behind this, but in general, when a metric is gathered and there was a span in scope, so span in thread local, the information about that span is getting attached to a metric. That way, we are correlating the 2 dimensions, the 2 signals. So there are metrics from which you can jump to a span. So over here, we have one, so we can jump to that one. Maybe we will going to be lucky. And we are, because we have one let's say request that got processed, and it stopped on the proxy service. So the T service got a request, then we sent a message to Mongo eventually, and it stopped on the proxy service on the quota side, and that's it. Like, what is this quota? Like, I have no idea. Now, what I can do is I can ask the proxy service team and say, hey, like, what is going on, right? But another thing I can do is I can go to their dashboard, because it happens that they have a dashboard. Maybe that will tell me more. Proxy service. Okay, quota request and throughput. Now, apparently, we can see more or less the same, that we have 3 requests per second that are denied and 2 requests per second that are accepted. Quota request, what does it mean? So if there only was some way of going to the documentation of observability data. Who loves writing docs? Okay, anybody? Bruno loves writing docs, so that's the only person. So what if there was a solution that if you have observability within your system and you describe it in a special way, and your system, like, and your code gets scanned, and it converts your blueprint of what your observations are to a doc? Wouldn't that be perfect? So, like, if you're using micrometer observation and you design or define your observations in a special way, that it's an enum, that has implement something, never mind, we will, using one of the tools, convert that information into an ASCII doctor format documentation. And what I managed to do is to add it as an HTML page to the proxy service. So that way I can read about what is here. So anything you've seen here, except for this line, is generated from code. So what I can see is, oh, there was this quota observation. So observation related to request quota calculation. In case of going over the maximum allowed request rate per second, rate limiting will be applied. Okay, so it's rate limiting. And now if we scroll down, we can see that for spans, this is the section for spans, we can see that we're going to have the max rate, max request rate, so max allowed request rate, and other stuff, right? So if we go back to our the proxy dash, no, here, to this trace view, we can see that indeed the max rate is 2, and at this point we went over it here, so the quota allowed is false, false, meaning that we started to rate limit. So what can we do to fix this? We would have to do one of the two things, either wait until the quota gets refreshed, which is kind of not a good idea if we have production traffic, or we have to ask our bosses to take out the credit card and swipe to increase the quota, which, let's say, they did, and automatically what should happen is that our throughput should change back, right? We'll see about that. Now, hopefully that changes in time. So what we managed to do so far is we started off by trying to go into the logs, but they didn't work. Then we managed to go to metrics, and using exemplars, we jumped to tracing. And we've managed to fix already 2 problems related to throughput. But those are easy problems because they are related to concrete issues. Wait a second. Okay. They are related to two concrete issues that give like an immediate output, saying, I have an exception, right? Or there's a null pointer, or I have a concrete status code that helps me out solving that problem. So you can see that we've managed to fix the throughput problem. So I guess that could conclude everything, but apparently not, because now I have latency. So again, we fixed 2 bugs, and now we have a problem with the latency, because you can see to the left that we used to have around 20-something milliseconds, and that is getting confirmed also by looking at the histogram buckets that we pushed up. So all of those buckets show you that a given number of requests were in a given scope of response times. So there were like 12 requests within the 14 to 15 milliseconds of responses. Now it's got far, far worse. So how can we solve that? We can look at the exemplars again and pick one of the previously working cases, pick one of the current ones, and look at them side by side. There you go. So now we can see that this one to the left took 15 milliseconds, and this one to the right took 166 milliseconds. So why is that? So if we scroll down, we can see that, for example, the T-leaf service communication is, the T-leaf service is around 5 milliseconds. The water service one, if we are able to see that, now it's 153 milliseconds, and we used to have 4. So something is wrong over here. So let's try to look into that. So apparently, the only thing that happens in the water service is that we're going to the database. And now the connection-related spans are much longer. So why is it so? Is the culprit the database? Let's check it out. So what we can do is we can go to a different dashboard. So Spring Boot instruments quite a few things for you. For all the applications that were using the relational database, we've added an instrumentation library that uses micrometer observation and knows how to instrument data sources. This is why we could check the queries and parameters. But also, the data source itself has metrics that we can check. So if we go to the water service, we can clearly see that the connection time has gone up a lot. Right? So that means that there's a problem with the connection to the database. Now the question is, why is it so? There are different options. Number one, for example, there was a lot of network calls and the bandwidth is getting used in maximum. Another problem is that somebody stepped on a cable, or there's a problem with the database. Or I just have to disable the toxi-proxy instance that I have set, which is introducing fake 50 millisecond latency between the application and the database itself. And there's a high chance that that was the problem. So after I disabled the fake proxy, the fake latency, we should see the latencies falling down, and we can already see that, right? One more important thing, if we go back over here. So from traces to logs, we can go, assuming that we'll be able to do it. Maybe in the meantime, something got fixed. No. So there's a problem with log. So in general, in a normal situation, for example, an hour ago, when it worked, what would happen is, apparently Loki is even down because there's connection refused. What will happen here is you would see all the logs correlated with the same trace identifier. So this is the way we're correlating traces and logs. But is there an option to, for example, correlate somehow traces and metrics to go between those dimensions? And there is. Because when we're doing observability with micrometer observation, what we're doing is we're instrumenting once, and we have multiple benefits out of it. So we are using the same set of attributes, as you can see here. There are some attributes, but we will use the same ones both for spans and for metrics. That means you can create queries that are parameterized. Like, for example, I want to look at latency. And now what happens here is that we have a parameterized metrics query, the parameters of which are coming from the span. So that's fantastic because due to the fact that we're using the same set of tags, both for metrics and traces, you can do such parameterization and you can get the other dimension that you need here, right? So right now we're looking at traces and metrics at the same time, related to the same thing, or as close as possible, right? Because we took the attributes from the span itself. Okay, I'm going to show you one more thing, and the important thing is that everything that I'm showing you is applicable without any agents. It's just because we have micrometer observation of the class path together with micrometer tracing for distributed tracing and micrometer core for metrics. And Spring Framework 6-based libraries are already natively being instrumented using that framework. Okay, last but not least, let's talk about, oh, you see, that the problem is fixed. Let me check my email. High latency T-house resolved. Everything is resolved. Fantastic. So now, this is the UI on the reporting service. I've written it in Vaadin because I wouldn't dare to write it. I mean, it's not as great as this one, but this is the closest I can get. So now what it does, it's going to Mongo, fetching 100 results, and printing them out in a table. And now if I want to filter, for example, by tleaf, I can do sencha, and it takes a lot of time to do it. Why is it so? It's because I have 2,039,000 entries in the database. So apparently that's a lot. I'm no MongoDB expert. And now, what can you use ChatGPT for? Since we're in 2024, I have to mention AI, because otherwise my talk will not be good. So the way I used AI, or ChatGPT for my presentation, was I explained to ChatGPT that I am doing this presentation. I don't know anything almost about MongoDB. Can you please help me create a small issue that I can, using observability, find and resolve? And it told me, yeah, I can help you out, and gave me snippets that didn't compile, obviously, but they gave me an idea of how it can work. So let's try to fix the fact that it's a little bit slow. And it turns out that I have a dashboard for the reporting service that obviously doesn't work, of course. Okay, that's highly unfortunate. So we were here. So in essence, the idea was that we have the metrics from the. Why is it so? So that we have the metrics from running the Spring Data Mongo, but apparently I don't have it for some reason beyond my understanding. And actually, let me try to write this in Prometheus. Maybe there's something really wrong with Grafana here, I don't know. I doubt it though. Okay, interval rate, let's do 5 minutes. Come on. 5 minutes and 5 minutes. Okay, I don't know. So in essence, what I was about to show you is that there was this, where is it? The rate of running the MongoDB, or maybe I can just check the MongoDB ones. MongoDB, I won't find it. Anything here? Okay, there is something here. But this is some of the duration. Let's take a max. Maybe that's going to be 2 seconds. Max, that's a gauge. Okay, so maybe that's going to help somehow. I doubt it, but at least I'm going to show you anything. So let's look at this one. It's a max. Can we see it? Okay, we can see something. Oh, get lost. Apply. Okay. So we care only about the find. So it takes a little bit of time to fetch it, and the idea was that I asked ChatGPT, how can I fix it? And it told me, you can apply an index. If there are any masters of MongoDB, I'm really sorry if I do it in a noob way, but I got a fancy UI to do it. I'd click create index. I type in tleaf, which should be ascending. Now it should take 10 megabytes of size. And maybe, but I really did it fast right now, maybe we should see that there's going to be in time a decline in the query duration, assuming that my Gatling is still running. It is. So now we don't see anything. Right, whatever. You get the idea that, like, assuming that I did it right, it should drop. Okay, let's end this misery now, because it's humiliating. So what I've managed to show you, oh, now we even have a drop in successes. That's fantastic. What a beautiful demo. I'm so happy. So what we've managed to do is I have failed miserably to show you everything I wanted, but I think I've managed to convey the message that observability is hard and undeterministic. No, I'm joking. So the problem we were able to solve was we found some bugs. We used metrics, tracing, and logs to go through them. And using micrometer observation, we've managed to get the instrumentation using the pillars that I mentioned, and we've managed to fix those problems. Now, maybe I will be able to show you one more thing, which is assuming that anything works still. Okay. Does it work? No, it doesn't. So apparently my laptop just is on the verge of dying. Okay, I'm gonna skip to the second part because this is useless. Okay, so what I'm gonna do right now is I'm gonna stop everything because this is pathetic. And we have still 10 minutes. I should be able to do it. I was wondering, like, what would be the best way to show you how really the instrumentation can be shown to you, how it's working under the hood. And what I came up with is, I could always do some slides or something like that, but maybe an interesting idea would be to create a fresh new project using, I don't know, Maven archetype, and just write it completely from scratch, right? So this is what we're going to do. I will do Maven archetype. So I generated something, group ID, com example. The font is ridiculous now. JNation 2024. Whatever, snapshots, yeah. Now let's go to JNation and I will open it in IDE. Okay. Of course, let's skip no, 1.5. This is nice. Java 1.7, JUnit 3. Whew, that's nice. Let's remove all this crap. And now, because of course I don't remember it by heart, but we could use Spring, but everybody uses Spring, so let's use something else. What I will do is I will use the Javelin framework. Who uses Javelin? Nobody. Who has heard of Javelin? A couple of people. Okay, so we're going to use Javelin as the server-side framework. Essentially, it's a small HTTP server, and we're going to use an HTTP client to send a request to an HTTP bin service that I'm running locally. HTTP bin is a service that allows you to look at your requests and check out the responses, various things, right? It's for testing. Okay, so I will, because I don't have a lot of time, I will be copying some of the dependencies because I don't remember them by heart, and I will make a lot of mistakes. So I'm adding the Javelin bundle, NSLF4j API, because I will be adding logs later on. Now I will go to Javelin documentation, and I will copy the hello world part that they have. Okay, we do this. Okay, so now let's start it. Okay. So now if I call HTTP 7070, I get hello world. It's as simple as that, right? So now I can have a before handler, so I can do something before. Let's say that I'm going to add a logger, private static final logger, logger factory. app class log info. So you can do something before a request is getting processed. You can do after, log info after. And this is what happens when you're processing the request. Here, sorry. Over here. So let's do log info processing. Whatever. Let's rerun this. Let's see if that changes anything. Okay. Okay, and now we should see before processing after. Great. So now what we will add is we will add micrometer. So to add that, we're adding the micrometer BOM. BOM is a special POM file that contains all the versions, so you don't have to provide them yourself. So once we have the BOM, we're going to do IO micrometer observation, and that's it. And let's refresh. So now what we will do is we will add the observation registry. Create. So for an observation to be created, we need a registry. We will configure some stuff on the registry later on. Now, in the before section, what we will do is we will create an observation. So before the request gets processed, we're going to do start. We're going to call it like, I don't know, before, whatever. And we're going to pass an observation to it. And now here we're going to do scoped. So if some stuff should happen like within the scope of this block later on, it should be put in this such a block, because that way, for example, you'll be able to enrich MDC, put some stuff in thread local, and then clear it out afterwards, right? Now, how will we pass stuff between those methods? You can create an attribute, for example, ops, and pass in the observation over there. And over here, we will retrieve it, observation. That way you don't have to use any thread locals or anything like that. Ops. Observation. So here we have the observation. Now we could put the, for example, a child observation here. So we're going to do scope, put this inside, and we can create another one, child observation, because they come for free, almost for free. You can use as many as you want. Child observation registry, and here we will do observe, which means that automatically the observation will be started, stopped. If there's an error, it will be put there, etc. So now in the after block, I'm deliberately not putting the error one because I don't have time for that. And of course, I don't make mistakes, so there'll be no errors. So here we do context, and after we can put observation scoped. And here we will do observation stop. Okay, let's rerun this. And what will happen now is nothing will change. And that's because we just added the instrumentation code, but we have not added any features to it. Like, we have not configured that to calculate any metrics or anything like that. So now, since I have 5 minutes left, I will just add everything together. So what I'm going to add right now is I will add the registry of Prometheus, the tracing part. There you go. So right now I will add capabilities related to tracing and metrics. I will copy the logback file as well. Resources. There you go. So the logback is configured in such a way that each of the log lines should have a trace ID and span ID taken from MDC if it's there. If not, just put zeros. Okay, I think I need to add one more thing, which is logback classic and different dependency management for micrometer tracing as well. Okay, let me refresh this one. And now, actually, I think I will even maybe show you the finished part almost. Oh no, I'm going to copy it. Okay. Okay, because there's going to be too much text. Okay, so let's start with Prometheus first. Okay. So I literally have taken this code from the Micrometer website. So essentially what it does, it's configuring something which is called Prometheus meter registry, which will, for your metrics, create the, for your observations, create metrics if properly configured. And it also creates the metrics endpoint to which it will populate with Prometheus format of metrics. Okay. So we do Prometheus, start Prometheus endpoint, whatever. And now to add this capability, what we're doing is we are adding a default meter observation handler, which this is an important thing. Micrometer observation works on the basis of handlers. So I'm going to show you that in a second. It reacts to certain events that happen in your system. So I could create over here, we can do it here, my observation handler, observation context, that can react to various things. So let's say I'm going to do just on start, because it can react on stop, on error, etc. And over here, I will system out my demo didn't go well, right? And I will do true over here. And now to add the logging capability of misery, I can just add observation registry config handler, and now I've added a new capability. So the instrumentation code has not changed at all. And now we have added two features, the metrics one and the logging one. Okay, and now we can see that the tracing related stuff is in the logs. Now if I send a request, I get the hello world, and if I send another request to Prometheus, I guess this one? No, metrics, it's metrics. I get in the Prometheus format, I get for the observations, the before and the child, I get the metrics. So in the instrumentation code, there was no notion of tracing or metrics or whatever. It was added as a feature. So last thing I'm going to show you is in the sample that I have that is running already. What you can do is also add the tracing capabilities. I mean, there's a lot of configuring here, so don't be worry about that. So if you add the tracing capabilities, so first you have to configure a tracer. Let's not go into the details, it's not that important, but you configure a tracer, and then you configure a set of handlers for receiving, for sending, and all the other cases. So I'm going to just run this. You can later on check the code. And what happens is that if I send a request that has the trace information in the headers, oh, come on. Okay. This is the trace ID. I should see that also over here in the logs, right? So just by instrumenting once and configuring the tracing capabilities, stuff just works out of the box. Okay, so I'm out of time. Do we even have time for questions or not really? We can have time for questions. There you go. And sorry about the complete disaster. It worked on my machine. Yeah, go ahead. He said great demo. That's great.
The question is, Micrometer has a Prometheus format. Does it have also OpenTelemetry format?
So the beginning of the question was very nice to me that my demo went fine. Then was the question if because you could cut a little bit, that Prometheus, Micrometer has the Prometheus format, does it have the OTLP format? Yes. So in order for that to happen, you would add over here new OTLP meter registry. I don't remember the exact syntax, but we have it. It's a different dependency, I think. I would have to add the registry over here. I think registry OTLP. Oh yeah, there you go, OTLP. Let's refresh it. I'm in the offline mode now. Why is it happening to me? Okay. Oh, because I wasn't on the plane. I work offline. So, can you repeat that because nobody? Okay, as is my demo. So the comment was that the latest version of Prometheus accepts also the OTLP format. Yes, you can use it like together. I can quickly show you that. Now new come on, new OTLP meter registry, and that way I would start doing it in the OTLP format. So what is great is no instrumentation code changes, right? Any more questions? Oh, go ahead.
If the trace ID is not signing in the request, the application can create the trace ID?
So yes, absolutely. And it not even it can, it must create a new trace ID. Why I added it to the headers is to show you that the inbound instrumentation works, that we are able to parse the request, take out the trace ID and propagate it further on. Because normally a new one would be created and continued. Any more questions?
Thanks.
Okay, so is there one? Okay, there is one. Oh no, there's none. Okay, so that's it from my side. If you want to talk to me, we can talk offline. I do vouch that it worked. You can check my other videos that it did work, and I will just, out of misery, format my drive, I guess. Thank you so much.